Happy New Year to everyone. This is Matt Podwysocki, aka Bluer Than Blue Falcon, aka Lambda Calrissian, back with you for yet another part of our series of learning RxJS together. So, where are we today before we left off, before I took a little bit of a break for the holidays? So I'll skip a lot of what we've already covered because there's plenty that you've been able to see over time, and hopefully you've looked at the YouTube videos that I've posted already, and can go back and look through them and learn at your own pace. But the very essentials is, we have an observable. Here's the basic contract with the observable that you subscribe to with an observer, and the observer has three possible callbacks of next being called 0 to infinite times, followed by an optional error and or completion. So then we showed how basically you create these observables, and then we have this other concept of schedulers and so on and so forth. And it really didn't get interesting until obviously we started to talk about piping and moving some of these, starting to combine some of the sequences together. I did update our work here so far, in that I added some plucking and tapping to the original map and filter post, and the reason why I did that is because I was trying to find a way, a good place for it to fit in a way that made sense in terms of tap and pluck both being fairly useful operators. So if you're not aware exactly what tap and what what pluck are used for, tap is a way to do very naughty things, as I say, more along the lines of causing side effects or something on your streams. So for example, if you need to do some updating of a progress bar or something, tap can be very good for that. So let's quickly take a look at tap here, and that's a way that we can, as you can see, you can see when each operation happens along the chain. So for example, if I have 1, 2, and 3 here, then I can tap into that, and so for every next item that comes through, I can tap and take and look at the item, inspect it, do whatever I want to. Just as well as for completion, we can do that there. And if you want, we can take a look at the documentation. I highly recommend you do. It's RxJS.dev. And so looking at there, we can go then to tap. So tap takes a partial observer, or it takes these three handlers. I don't like necessarily doing that. I like being more explicit about those things in terms of which ones you want, whether it's whether you're handling the next or the error or whatever. It's better to have that kind of in a more idiomatic way, just as people do for, say, named properties or named parameters in C#. This is kind of a pretty good way of saying that, but hypothetically, yes, you could just use 3 callbacks and setting the ones that you don't want to null. Like I said, it's a preference, and everyone can basically use your preference. I won't criticize, but at the same point, would I like you to use the more idiomatic style of a partial observer? Absolutely. So the next piece is something along the lines, if you're already familiar with Lodash or something akin to that, that's the idea that we can take a piece of data and we can start to pluck pieces from it. So for example, we can if I wanted the name property, for example, I can say pipe and then pluck, passing in the name instead of having to call the map function directly and projecting the item and saying that. But going beyond the standard one level deep, you can go recursively deep if you want to. So, for example, if you're dealing with mouse events or something to that effect, you're going to want the event's target value. What we don't allow is you to use like dots in the names for these properties that we're looking up, and the reason why is because in JavaScript especially, that's perfectly valid in terms of a name. In fact, we can fire up node here, and we can say var foo is equal to just a new object here, and then I can say foo of foo.bar is equal to 42, and then we can say what is foo? Well, it has a property of foo.bar. So the reason why we wanted to go the more recursive style made a little bit more sense in terms of we will just keep on diving back into the code and pulling out the value as it comes along. So those are two fairly simple simple operators. They're not really huge, but at the same point we're going to be using them going forward, and so just trying to let you see the maximum amount of things that you can do with Rx, I think is really key here. Like I said, I really want you to use your imagination through this series, because what we're really doing is just trying to cover the very basics and then letting you, the user, kind of use your imagination as to the things that are the art of the possible. So moving on after that, we did the scan and reduce, and then we starting and appending data afterwards. Then moved on to subjects, and then creating our own Redux clone. And towards the end of this series, or even part of this series, because I think ultimately this series should continue in some form or another, whether it's daily, weekly, or what have you, in some form. And we'll be talking more about some of these more advanced scenarios, as well as highlighting some of the pieces from the RxJS community, because it's a very rich community. When I started creating RxJS back in 2010, 2009 to 2010 timeframe, nowhere did I think that it would grow in such a way that it did, and take on a life of its own, and seeing what the community was ultimately capable of. So that really just blew my mind in terms of some of the things that people are doing. And so what I want to do is I want to focus on some of those things going forward, showing what the community is doing. And what would be really cool is to have some of those people join us here for some of those videos, and then we can upload them later. Now, I think we stopped before the holidays with throttling and debalancing, but I don't think we necessarily covered a bit of the code. But I just want to walk you through exactly what I mean by throttling and bouncing, because once again, that's a fairly interesting topic, especially when we're thinking along the lines of an auto-suggest scenario. So if you don't know what I'm talking about with an auto-suggest scenario, imagine me just typing in here to the URL bar, and I want answers along the way. And so to do that in JavaScript, in plain old JavaScript, is not necessarily easy. I'm sure there were jQuery plugins to do that way back in the day. But doing it yourself with vanilla JS was already hard enough in terms of how you do it. In fact, I've got I think a slide and a half worth of code that's really required in order to do that, because it encompasses a number of things. First is obviously is taming the user input, and what I mean by that, taming the user input, is that we are going to throttle it a little bit or debounce it just a little bit, because if they're really fast hypers, we don't want each and every piece to come through. We want to wait a little bit until the caffeine has kind of kicked out of their system and they can type a little slower or something, because the last thing you want to do is absolutely flood the system with a number of requests. So cool. And then the other aspect of that is because we're dealing with key up events, for example, in JavaScript, the last thing we'd want to do is fire these particular key up events, even though the text itself hasn't changed. For example, if I'm going left or right or up and down with my arrow keys, those are key up events, but the text itself hasn't changed. So we would want to do something like distinct until changed in terms of trying to throttle the user input. So let's go back to day 19 and talk a little bit about the differences once again between throttle and debounce. So throttling is a way that we can enforce the maximum number of times a function can be called over time. So it's only going to be able to be called once over X amount of time, whether it's a second, 2 seconds, half a second, etc. That's comparing and contrasting to debounce, which is that, okay, I'm going to make a call and then I'm going to, or rather I'm going to take some input, and if they stop for half a second to a second, whatever the time window is, then and only then will I fire the event. This is really obviously the one that we want to use for our auto-suggest scenario. And so to understand that is that it's now becoming an asynchronous operation, but in the scope of observables, it all just flows through as one single type, and it's really really nice to be able to to think of everything through your stream as observables. So in here, throttle, we've got a sample implementation. So if you take a look through the documentation here, by the way, if you don't know, I've moved the URL here, so it's no longer under my name. It's moved over to the ReactiveX org, which is the home of the reactive extensions pretty much for most languages outside of .NET. Whereas the .NET one lives over in the .NET Foundation, and the rest of them live in ReactiveX. So just makes it a little bit more official, easier to find, instead of having to memorize my last name. So anyways, so if you want to understand what throttle is, here's a base implementation of it, and it's really not that far off from what we have in Rx itself, which is the idea that if it's after that time window, call the function, set the call function time, and execute it. Otherwise, if it's still within that time window, just do nothing but return and don't do anything at all. So we'll have this throttle handler to make sure that, for example, our event emitter can't keep sending data at an incredible rate. And we have two ways in Rx to deal with that, either throttle or throttle time. Throttle time being obviously the easiest one to reason about, in the fact that you can give a relative time from now, such as half a second, and then you can throttle it from there and go forward. So cool, easy to understand. Now, what we also give you the ability to do, and this gets a little bit trickier, is the fact that we give you a way to use the throttle operator with any given observable at all, whether it's interval, if you want to use it much like it is underneath the covers, then you can use interval. Otherwise, you could completely create your own subject, and it would be up to you as to when that next happens, as to when the throttling operation happens. So it's really up to you in terms of when that fires. but it could be any number of things that that trigger it. But like I said, is any observable at all, so it could be your own custom, it can be your own subject, whatever it is. Now, to bounce, on the other hand, was a little bit trickier in the fact that you have to use set timeout or some sort of callback mechanism to basically move things to the background timer to make sure that this happens or doesn't happen over time. So as the next one comes in during our debounce function, if the timer is set, clear it. And then set the function again, and if the function then waits a specific amount of time and the timeout's cleared, then it'll fire. Otherwise, it will keep clearing the timeout, meaning cancel, 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 and until we finally get the right one. And we have both, just like we have for throttle, we have for debounce, we have the ways of doing debouncing over time with the selector or with the relative time. Cool. So as you see here, I have a number of pieces that I've already created here, and some of it's still ongoing. Like I said, I got a little sidetracked during the holidays. But what I wanted to do is kind of give you a preview of where we're going, and obviously it might not end at 25, it might not end at 26. I could go for the full 12 days of Christmas experience, adding on top of Advent itself. But I just wanted to go over some of these things that I think are fairly interesting. Because by the time we get to 21 and beyond, we're starting to get into some of the more advanced scenarios. So we might want to cover back some of the fundamentals again. And like I said, feedback absolutely open. Please do give comments and feedback in terms of the things that you really do want to cover. And as well, the chat is open as well. So if you want to use that as the mechanism, great. So the next topic we're going to cover is skip and take. So it's a fairly easy kind of thing to think about in terms of taking X number of values from a string. What makes take, of course, interesting is the fact that it can take an infinite stream of interval or something else like that, and then truncate it after X amount of data. And that's helpful, for example, if you wanted to only have a button click once and then terminate, you would say, from events, whatever button dot and then click, and then take one. And take one would then not only take the one value, but also finish and close down the observable. And why that's important, for example, in that once scenario, is that it will remove the handler for you since the actual logic finished. And that's all part of the teardown handler part of the observable itself, the observable contract, which means that, like for example, in the creation, and then you return a function which has the teardown mechanisms of a particular observable. So take, really, really useful in terms of truncating the data that you have over time, that I only want 20, 30 items, whatever it is. And you can also do take last. So for example, if I want to take the last 5, this is looking at a more finite stream. So if you've already got a finite stream and you only want to pick the last 5 or 6 or 7 items from that particular list, then you can do that here using take last. But once again, we're talking finite streams here. Whereas with take while, we can once again go back to infinite streams. So like I said, we have all of the code available to you here. So if you want to skip back and take a look at the code for day 20, we sure enough have all of these things where we have take and skip and so on and so forth. And I highly recommend that you go through there and make these samples yours, because what I'm really doing is I'm trying to just show you quick and easy code examples. So for example, what take 3 would do on an interval of, say, half a second each. Let me close that, and then I can go to npx ts node 20 index.ts, and we can take 3 of these items, so it'll be every half second, and then once again it completes. That's really cool in terms of being able to show that we can take something that's potentially infinite, and then taking that and shrinking it down. The same applies for take while, although here I'm using a range, but really I could just say interval here again, and half second, and going between those, and then saying and then running this again. What's nice about the Visual Studio Code experience, obviously, is you get nice documentation here, including our documentation as to all of these examples as they run through. So once again, highly recommend that you play around with these code snippets, especially if you're using TypeScript. It really is very helpful. So running through these, we can then look at, for example, we can do, this one is more of my favorite, which is we can take this, and we can say we have a range. And so what if we wanted the first and next items together in such a way that you have a delta? So the delta here is the ability for us to take one signal and then combine it with another signal, skipping one ahead. So we'll always have some sort of delta that we can calculate between these two by going through and setting up these pairs. So that's kind of cool, how you can do that. So what you can see here is 0, 1, 1, 2, 2, 3, and 3, 4. So once again, if you need that previous value with the current value, skip 1 and zip are totally great pieces for you to play around with. And I highly recommend that you do. The more interesting aspects of the skip and take aren't necessarily for these predicates and numbers, but more along the lines of take until another observable. So take until with another observable is most likely used, or most likely used a lot of places with something like drag and drop. And to describe drag and drop is fairly simple, in that you want to do mouse down and then mouse move, take until mouse up, and it works itself out in such a way, in using the parlance of Rx, to pretty much be able to do that is to be able to express in a very nice notation to say do this and that, then this, until that. And so let's walk through the code and show you what I mean by that. So we're going to import from events, and then map, merge map, and take until. And then we can get our element that we care about, such as a button, any particular element on the screen. And then we can go for mouse up and mouse down on this element. We have our mouse downs and mouse ups. And then anywhere on the canvas itself, we can do mouse movements. So what we're going to do first is we're going to take the mouse down. So the mouse down is obviously the trigger for the entire mouse movement piece. So once that happens, what you're going to want to do is you're going to want to get the starting coordinates, and the starting coordinates will allow us to be able to calculate the delta as time goes along. So we can get our start x and start y from our mouse down's offset of x and offset of y. Next, what we do is we take the mouse movements. So we're basically saying, okay, merge map, remember, is mapping then merging together. And since these are synchronous-ish, there's no real worry about out-of-order values as opposed to something like as opposed to our AJAX requests or anything like that. This perfectly good to use merge map here, and then we'll say merge map and taking the mouse movements. So now we've combined the mouse movements together, and then what we're going to do is we're going to calculate inside of there with a map the delta between this start x and start y and where we currently are with the mouse movements. So that gives us our delta. But the most important piece is right here, take until. So take until will continue to do this, and we'll continue to listen to these particular mouse movements and so forth until that mouse up happens, and then the stream is then terminated. And then we'll come back again when the mouse down happens again and start it all over again. Once again, getting the starting point, and then moving along, and then stopping again when that mouse up happens. So you're able to do any number of things, whether it's drag and drop or just even drawing on an HTML canvas, is all using the same kind of logic in terms of getting the origin value and then calculating the delta from that. But the really easy part obviously is just saying the saying that we're doing here, which is to say that it's mouse down, then mouse move until mouse up. And we're basically saying that in code right here in so many words, whereas we're saying mouse down, merge map, mouse move, take until, mouse up. Now we have, once again, just as we have the take values, we talked about the skip values as well. And so if you understand, coming from the skip side, the takes side of things, skip is really no different in terms of you can skip the first two values, you can skip the 25 values, 100 values, whatever it is, or you can skip while a certain condition holds. Such as what its index happens to be in the grand scheme of things. Those are really cool in terms of skip while and all of those sorts of things to skip data until you really care about that. And then of course if we have a finite stream, then the skip last makes a little bit more sense in terms of we're going to skip the last 5 or the last value. So for example, if the last value of our stream is a terminator or something that we don't care about, we can discard, we can say skip last 1 or 2 or 3 or 4 or whatever it happens to be. Now that brings us then to skip until. So say for example, we want to skip listening to certain events until, say, a button has been clicked or something to that effect. I don't want to listen to these events until some other stimulus happens, and that's skip. That allows us to be very fine-grained in terms of our control of our events. So we can say skip until that the open button was clicked, whatever it happened, or an open event happens. And then we can terminate it whenever close happens, whatever close happens to be, whatever stimulus, whether it's a button click, whether it's an event, whatever it is, you can then say take until. So you're really closing down this window of how you're going to play with events and massage them, and only take what you really need. from there. So that's all I really wanted to cover today, because like I said, we're going to get into some more advanced scenarios shortly, especially when we start getting into error handling, publishing and sharing. Buffers in Windows, not necessarily a huge topic, and I think we can probably rearrange the schedule a little bit. But I just wanted to kind of throw something out there because I'm not quite finished writing them all, because quite honestly there's a lot of material to go through, and I think tomorrow we'll go through the error handling very much in depth in terms of being more hands-on, and this was more of a catch-up to where we had left off and where we're beginning again. So with that, I want to thank you all very much. We will start again tomorrow. Once again, I want to thank you all very much for coming today. Do leave any of the notes that you want me to cover in the future. Do either leave a chat here or let me know on Twitter at Podwysocki, on Twitch here, Bluer Than Blue Falcon, and you can find me on YouTube as well. So thank you all, and I will catch you all tomorrow. Thank you all. Bye-bye.